Okay, that's the formula that I mentioned just now. Volume is equal to area 1 plus area 2 divided by 2 multiplied by the distance. Distance is the, remember the challenge, the next challenge minus the previous challenge. So, the L is 40 minus 20 meter. This is the area you need to calculate. The same thing, this is the area you need to calculate. A1 plus A2 divided by 2 multiplied by L. So you get the volume between the two channels. Of course, you have 40 kilometers of road, there will be a lot of calculation to do that. Of course, nowadays you have Excel. Nowadays you have even BIM, information modeling, that can probably do this calculation for you. But you need to know the fundamental principle of how this thing is done. So that whenever you key in the computer, you know. I don't want you to be key in 20 you letak 20 chain. Alah 20 meter. Ataupun you letak 20 millimeter ke habis. The computer will accept anything. Right? Suddenly you got a lot of very small amount of soil to be removed because you use the wrong unit. So that we don't want that to happen. Okay, there could be other modified calculation, but those are the basic formulation that we use. You will look at this on your own. Okay. Next thing is, this is also important when we do earthwork operation. When material from cut, when you cut, right, and you bring to field area, right? You cut over here, over there you need to fill. So when you say, okay, I have a lot of excess earthwork here, I can use it to fill them. So you do calculation. So you will you check the cut before it go to the boundary for filling is 10. Let's say 100 meter cube. Oh, okay. I have got 100 meter cube of soil here. My over there I need to fill 90 meter cube. Or even this is 100, the same thing. So okay lah. Now I've got what we call balance earthwork. I've got 100 to be cut, 100 to be filled. Oh, lega. I don't have to throw away the soil, or I don't have to buy more soil. But the thing about cut and fill is you need to consider another thing before you make the conclusion. It is called shrinkage factors. The shrinkage, the shrink of soil. How does it shrink? I'll tell you. Generally in the range of 1.1 to 1.25 shrinkage. That means the soil from cut, you kata 100 tadi ni, when you go to site, it will shrink. If you have 100, when you fill, you will not be the volume of fill that it can occupy will not be 100 because there will be compaction. You excavate the soil, you bring it over there, and you compact that. At the same time, the soil that you excavate before, it was not compacted. It was in a natural site, right? So we don't know exactly what is the density. So the density of fill and the density of existing soil on the ground is not the same. So in road construction or in earthwork operation, when you fill the site, you need to compact. This compaction will make the soil into higher density. You need this density to provide the strength to support the building on the road. So that is why shrinkage factors are in the range of 1.1 to 1.25. That means 100 you need to divide by 1.5 or divide 1.1. Then you get what is actual volume you can fill over there. Right? Or applied to the fill volume to determine the quantity of fill required. So the actual fill required is more than usually the actual cut area. So that you need to rationalize that. Otherwise, your plan will be not accurate and can cause trouble if you have an agreement with the soil supplier or whatever, and things like that. So if you cut over here, you fill over here, so you need to consider the what we call shrinkage, right? So that's cut in red. So that's filled in blue. So roughly, what would be how do we estimate this shrinkage thing? So it can be based on this illustration here. You can see this excavator is removing the soil or cutting the soil from the hill. 1 meter cube. And 1 meter cube of soil from the excavation. Once you go to, there's another thing, transportation. This 1 meter cube will become 1.25 once they are loose, in loose condition. Tadi dia slightly compacted, but once you excavate and put onto this lorry transport, it will occupy 1.25 because it is loose, or more space. And later on, when you bring the side and compact them, from 1 it becomes 0.9. So that's the shrinkage factors. Cut 1, fill 0.9 only. If you cut one, this is example. If you cut 1 meter cube, you can only occupy your fill space only 0.9, 92%. But even more important is your transportation. It will occupy 1.25. So you need to plan properly so that you have enough trees, enough number of lorry to bring the soil to site. You cannot say that okay, my transport here can handle or can carry 6 meter cube of soil, but there is loose soil. So 6 meter cube is based on this loose condition. So with 6 meter cube in here, over here is only probably 5 meter cube, right? Excavation. And when you bring to site, it becomes 4.8 only. But your lorry is 6. So this kind of what we call it operation, you need to be clear about it so that you can plan properly for your excavation work, your transportation of soil, and also how does that comply with your field requirement on site. You kata saya dah buat 100 lori, 100 lori kalau satu lori 6 meter cube, dah 600 meter cube cukup lah dalam BQ kita 600 meter cube. But the thing is that 600 meter cube is transportation. Actually, the less soil that you take and even more less soil that you provide for the field. So those quantity need to be what we call it rationalized, so that you have the right number, the right estimate, and then so your project will not be tak rugi lah. So that's about what we call shrinkage factor, very important in the work operation. Okay, remember just now we need to calculate the cross section for us to be able to calculate the volume. This is the principle. You can find this technique from online, from any textbook related to soil or earthwork operation. Just to give you a quick idea of what is the mathematics or the mechanic of this calculation. This cross-section area, this is cut, right? This cross-section area, we need to calculate this area. Let's say this challenge 0, starting of the project. Oh, it cannot be 0 lah. Somewhere in the middle. 0 meaning probably you have no cut, start from 0. The formula is H multiplied by 2b plus nh. Okay. N is the slope of the side slope of your excavation, and h is the depth of the excavation from the floor to the platform level, and b is half of the roadway. Remember, b is half, right? 2b here. 1b only halfway. One way this way, the other this way. So b. So h to b multiplied by n and h. What is n? What is 1n? That is the slope. 1, right? 1. Then 1. What is n? 1. This is 1. 1, 1. Right? 1, 1. Right. That means this n is 1. Kalau slope dia sampai sini 1, 2 and a half. So 1 n is 2 and a half. So that's what this n means. What is the commonly used slope for a slope in road construction? It is 1.5 and 2. 1.5 for cut. The cut area, that means you cut this deep, the slope has to go 1 and a half. So 1 half. So the slope will be like that. For field, it will be 1, 2. 1, 1, 2. So from here, the field slope is milder. Go further away than cut. 1, 1, 1, 2. This is the slope. So that's what the n is. So when you need to do calculation, that's what you need to identify. That's how you know what is the n. What is the b? That depends on the width of your road. What is the road width? Standard national highway is 3.5, 1 lane. 2 lane, 7. 4 lane, 3.5 by multiplied by 4. Plus roadside, another 3 meters. So at least this one is 3.5, 3.5, 7 meter. So b equal to 3.5. 1b, right? You have 2b for your road, not only 1b. So jangan silap. Banyak your senior silap. When selalunya dalam calculation lah. Given b equal to 3.5, dia dua b tu kan 3.5. Actually 3.5, only 1b. This is 3.5, this is 3.5. Right? That's why bawah ini 2b. Okay, this is considering flat ground. You have flat land, right? Macam sekarang ni. It looks like this floor here. So you excavate like that. So that is the formula. Very simple. But definitely you are also aware, if you go to site, mana ada site flat ni? Ada bukit nak potong dia. Macam naik turun kan, semua kan. So sloping ground. So there are formula untuk sloping ground. So yang ni pun you tengok lah. So the area sama juga ada B, N tadi dah sebut dah. N, the S, apa semua ni. So all these things, the width. So you need to get all this dimension before you can calculate the area. But if the cross section is drawn according to scale, for example in AutoCAD, you can just click, right? But it must be drawn to scale. But that is not difficult nowadays, because most computer programs can capture that. They provide, they capture, they give you instruction. Even sometimes give you straight away the area. But you need to know what is the fundamental behind the calculation, so that you can key in. The computer will be asking you what is the solution. Okay, I'm trying to get everything done by 4 o'clock. Anyway, this is an example of average area method I mentioned before. For example, this is the field area. You want to fill something like that, right? This is the top of the road. This is the base of the road. So we need to be able to know what would be the cross-section area at challenge 320, section area at 350 and 400 because we only have these three information here. 320, 350, 400, which sounds awkward for a challenge, but I purposely have them in different interval. But in actual the situation, the interval will be consistent. Highway 25, the normal road will be 10. Okay, let's say now you want to find this whole volume of field, of embankment. So we need to be able to know what will be the first concession, in this case, challenge 320. Next section, in this case, 350. And finally, the last section, which is challenge 400. So I try to draw some illustration so that it will make things easier for me to do calculation. Using this concept just now, this formula. So I draw this trapezoid of section of the first one, which is challenge 320. The road width is 6 meters, 3 meters on each side, so 6 meters. The top of the road, 6 meters. Right? So in this case, this what we call this illustration should be terbalik ya, dari atas, dari bawah dua atas. But this is car, this is field. But it's the same temperature, same thing. It's just that now one is balik. So I imagine that the first challenge, the difference between the top and the existing ground is 3 meters. Depth is 3 meters, which is the H. 3 meters. The next one, the depth is 3.6, and the last one over there, challenge 4, is 4.6, higher. Meaning you start going higher, or the ground is getting lower, so you need to feel higher. So based on this height and the road width that I need, I should be able to calculate the area, right? This is based on certain slope, but you need to know the slope. You need to know what is the height that you need to fill in this case, and then you'll be able to calculate what will be the base here and so on. And based on that, you can do the calculation based on this formula. But the objective here is to get what is the area here. What is the area of that trapezoid? And that one, you can do any technique that you comfortable. But the important thing is to get the area of the trapezoid. That is all. Right? But it's as simple as that. This is just a formula. You can use your own formula. So once you have got the area 1, area 2, area 3, then the volume between challenge 320 and 400 will be first between 320 and 50 area, this area plus the area divided by 2 multiplied by the distance, which is in this case 50 minus 20, 30 meters. Next volume will be between 350 and 400. The length is 50. The area 1 plus area 2 divided by 2 multiplied by 50. So you get this volume plus this volume, then you get what is the total volume of the embankment of the field. So that's the thing. Let's say you get total embankment of 100. Remember just now, the soil that you need is not 100. You need more because of the contraction, the shrinkage, right? So usually we will prepare what they call a format like this. If I'm using Excel, for example, I will do this, right? So that I can have a formula to expedite my calculation. So what we'll do is I will write the challenge, mentally 320, 350, and 400. The area that I calculated, area at that challenge, area at 320, area of cross section, area at 350, area at 400, and then I can get an average between these two areas, 320, 350, I get an average. I know the length, and finally I got the volume here. Right? Same thing over here, 350 and 400. It has got the own respective area at 400 and 350, and you got the average here, and then you multiply by length and you get the volume. Okay. At the end here, you have what we call cumulative volume. Cumulative. For example, over here, from here to there, I feel I need 100 meter cube. Then the next one, 150. So cumulative from over here to the end is 250. Right? 100 plus 150. That's cumulative volume. Okay. Why do we also come up with the cumulative volume? Because that information will be used later. Remember, I mentioned it before in a mass hall diagram. How are you going to plan the movement of soil along the road? Along the roadway. Where you will decide not to bring the soil over there, but it's better to buy the nearby from nearby quarry, or where you want to dispose of your soil instead of keeping the soil, because that will be more economical. So same thing. This is cut, this is field. So the cumulative volume will be go up and down depending on whether your calculation is for field or for cut. Right? Because it is cumulation. It can go up, suddenly they have got the cut. Let's say you started with cutting, so you have a lot of soil. Then suddenly you need to fill, so you use the soil, so the soil will be less. So along the way, you go up and down. Just like over here. So this is a more descriptive explanation on how we do the calculation using average and area method for roadway. So you can go from 1 to 10, right? That describe how you use that table that I showed you just now. So I need you to go on your own on this. So that's the answer for the example just now. So the first area I got 27 meters square, second 34.56, third one here 48.76. So using this calculation, between this challenge and challenge, I got 27 plus 34 divided by 2 multiplied by the distance, I got one volume. Another one from here to here, get these two average multiplied by the distance, another volume. So I total that up, I will get the answer. So basically that's okay, let us go to what we call mass hall diagram. This is something, a tool for you to manage your road project. One of the tools in managing road projects is mass hall diagram. What is hall? H-A-U-L is the transportation of excavated material from its original position to its final location in the work or other disposed area. So sebenarnya you need to transport when you excavate here. Where you want to bring the soil? Over there. So that's a transport. That is hall, we call it. So mass hall diagram on MHD is used to calculate the average. So we need why do we need this mass hall diagram? Why do we need this diagram? Because we need to calculate the average. Or sometimes it's called free haul. Average and free haul is the same thing in terms used in earthwork operation. Between TWO, between two given balance point. Balance point is when I will tell you what is balance point. Balance point when you start what do you call it? You transition from cut to field, or field to cut. Mass hall diagram also will tell the builder which way soil is to be moved. You have a road from here to over there. You have the soil here middle. So should you bring over there or should you bring on back this way? So the best on diagram will tell you that. You can plan. So best on diagram also will tell the builder which way the soil is to be moved, over, forward or backward, and the quantity to be moved forward or backward. And then another term is overhaul. What is overhaul? Overhaul is the authorized movement, hauling of excavation beyond the specific freehold area. Authorized means you are going to be paid for that beyond the freehold distance. Freehold distance means the rate of payment is different from the overhaul distance. So it's within the freehold distance, you will only be paid a certain rate of overhaul. But if your soil is going to be transported beyond the freehold, then you are going to use different kadar bayaran. So the overhaul is called the authorized hauling of excavation beyond the specified freehold distance. And what is what they call the transportation is going to be beyond the overhaul, right? Beyond the overhaul. That is authorized, meaning there will be no payment or the same payment. So the best thing is to discard. So you don't bring discard, so get somewhere else cheaper. So you can see in this chart here, this is the road, right? This is the road. This is cut area, and then this is field area. So you're going to the right. This one, the dotted one, is the freehold. Meaning this one is certain rate, because this is the transition between cut and field. So you cut over here, you fill over here, right? Cut over here, fill over here. This is what we call FH, is freehold. Now, the soil behind it will take a longer way to go to the field area. This is called overhaul. Overhaul. This is overhaul. So, your client will only agree to pay for the freehold and also the overhaul. Anything over here is called waste. Waste means you need to discard. Because it's not economic to bring here, transportation jauh dan sebagainya. Over here, you need to borrow. If you don't have enough soil to fill here, you need to borrow nearby. You're di Penang, di seberang sana, you don't need to bring the soil over there. You will get the soil over there in seberang Perai. Meaning you borrow. You call that borrow lah. Waste means I have a lot of soil here. Beyond the payment, so I just discard the soil. I don't need to bring the soil to seberang, which costs a lot more money. So that's the definition of freehold and overhaul. Basically, this is what we do. Remember the chainage, chainage? The freehold diagram will involve the chainage in meter, right? But you're going to work in US, or maybe some with the American company. For example, you are working with an American company in Dubai, they may be using the English unit, so you need to be able to convert that from meter to feet, right? But basically, it is the distance, or from one point to another point. So the y-axis will be the volume of soil. So where does this volume come from? Remember tadi kita ada cumulative volume from calculation tadi. along the way kita calculate kan, dekat, that cumulative volume. So we'll draw that. So the volume will start to go up. That's your next one. Okay. This is the profile, road profile. This road looks flat to me. Flat road, right? A to C is flat. Jaranglah lupa road flat. Okay, example. That is a profile, long section. The vertical alignment, up and down. But in this case, alignment is flat. The one at the bottom here look like a normal distribution. It's actually the mass Hall diagram. That is mass Hall diagram. So how to read or understand the mass Hall diagram? You see, over here when we start at point A, this mass Hall diagram, you know along the way when we construct road, there will always be cut and fill along the way. Cut and fill, cut and fill. Ada bukit, beton, turun, lembah, fill. But of course, there are some situations where you have your road from Gurun to Alostar all the way dalam pedang, so all fill lah. Banyak fill itu. Okay. So this is mass diagram, mass Hall diagram. So when you start cutting from point A, you start your volume from zero, right? Tadi kita from zero. And you start accumulating your inventory cube. Okay banyak. Once you sampai point B, now you need to fill. So you are using the soil that you have cut. Then the amount of soil in your mass Hall diagram will be less and less until habis, tak ada. Kalau ambil sini, habis bawa pergi sampai C, habis. Dia balance lah tu kan. Tetapi actually in practical sense tak nak habis projek tak habis because ada lagi depan ni, dia lagi nombor ni kan. So sebenarnya, so that means the mass Hall diagram panjang daripada point A sampai C sampai D, E sampai Z. American kata Z. So kalau orang tengok American movie, Z kata Z lah. So some movie ni dah taruh dalam American banyak mungkin ada Z lah. So anyway, A to Z or A to C. So there will always be up, down, up. So this is what we call mass Hall diagram. Now, what would be the term yang kita pakai tadi ni? Average Hall distance ataupun free Hall. Dia ada calculation lah, I'll show you now. So, usually this average Hall diagram distance will be determined earlier. Will be determined earlier dalam contract documentation. You will know what will be the average Hall distance, what will be the free Hall distance we call it, and what will be the overhaul distance yang dibenarkan. Now, the free Hall, let's say this is the free from, because remember the up and down ni dia bergantung kepada jumlah tanah yang potong dan so from A to Z dia punya curve ni mungkin ada yang panjang macam ni, ada yang naik tali turun rendah, ada yang lebih lagi kan. If this is the distance that you accepted, maknanya that means ada setengah location yang average Hall distance dia memang cover this voltage. Ada setengah location dia hanya cover sebahagian saja, yang lain dia di waste and borrow. Because kita ambil average, kita tidak ambil Hall distance setiap curve, tapi average of the project. Calculation, we will look at the calculation. Anyway, this is a Hall diagram. Cut go up, fill go down. So basically that's it. So another wider or greater range, example that shows greater range. This is the profile again yang tadi, profile yang tadi. This is card, field, dan sebagainya. Tapi in this case, that calculation untuk the freehold distance is already calculated. Freehold distance dah calculate. Freehold distance. And the calculation indicate that 50. As you can see in this program, this diagram, this is from America. Kau dalam feet. Tanda tu feet. And yard is LR, right? Anyway, yang penting tu mass flow diagram. Right? So, the hall limit dia 50 kaki, 500 feet. Berdasarkan calculation. So, you use that 500 to draw this boundary dekat each curve. For example, dekat sini curve ni, ini concave. From the middle you go 250 and 250 you got 500. So in between, another curve over here you letak 500 juga. So in between there will be area yang tak cover by the freehold. Area yang tak cover ni lah dikira sebagai, kalau kawasan field kita panggil borrow, kalau kawasan cut kita panggil waste. Okay. So that's how we know where to remove the soil, where to keep the soil. So you can plan kat sini nak jual kat siapa, siapa nak tanah ni. You know already. Dia cari dah siapa nak jual, your friend. Dia ada business, dia ada dapat maklum. In advance. Other than bila decide baru tahu nak buang mana tak tahu dan so when once you have got a plan, the construction plan, you know already where you need to borrow means you need to buy, or where you need to waste, you need to give away or sell away. Depends on. Another rule of thumb or indicator of what does this mass flow diagram tells you. A rising curve indicate increasing volume. Mass flow diagram yang nampak curve makin naik, maknanya volume tanah, you punya storage tanah makin banyak. Maknanya you potong tanah, cut soil, so you have a lot of soil reserve, soil that you generate. The maximum point on the curve represent the end of a cut. You go up, at the end, you start going down, meaning there's no more cutting, but you start filling. Definitely, of course, falling curve represent decreasing volume, because you use the volume yang you generate tadi to fill. So you punya jumlah soil yang you ada makin kurang lah. Duit dah kurang, dah pakai lah. Tadi dapat gaji, sekarang tengah bulan pakai dah turun, kurang lagi. A minimum point represent the end of field. So you di bawah, sebelum naik blade, end of field. So the curve maybe kat bawah, tapi sebenarnya dia dah started nak cut balik. Area at the end of the diagram represent a waste or a deficit. Ini yang tadi tu. I'll show you some last session. Maknanya at the end of the diagram, kalau your curve tu tak touch the line, tak touch the Y0, the line, that means it is a waste or shortage, right? Sama ada dia tak touch the line daripada bawah atau tak touch the line daripada atas. So that will tell you whether it is a waste or it is a shortage. Maknanya you habis lah projek sampai ujung tadi, you know already that tanah ni memang lebih ataupun tak cukup. Then you can plan where to buy or to sell. Any horizontal line drawn between 2 points within the same curve indicate a balance of cut and fill between the points. That means you ada curve yang naik kan, right? You draw any horizontal line dekat curve tu, that is the balance point between cut and fill between the 2 points. Okay? Okay, strategi. Strategi kalau dalam case you ada waste. Tadi remember tadi dekat ujung kali. Remember turun field kan? Naik cut. Turun field. Cut sampai atas. Maknanya bila cut banyak malah yang macam ni sampai atas dia tak turun balik. Dan so your mass flow diagram indicated that ujung projek duduk macam ni. That means the required amount of material to be waste dekat sini banyak ni lah. Ini kan ni volume. Y volume kan? Volume. Whatever the volume Y indicated lah, katakan 100 meter cube. Berapa lori dan sebagainya. So maknanya sampai ujung ni you kena buang tanah. Padahal you dah cut banyak lah. Sampai ujung yang dah buang. So bagaimana strategi nak pastikan bahawa dah sampai ujung just nice, tanah dah habis pakai. So that means in this case, ini contoh lah, ini one, apa yang dia buat ialah sampai ke sini excess material wasted at this location to minimize haul by reducing the area under the waste. Sampai sebelum sampai ujung ni, you tak kumpul tanah you. Sampai dekat sini, you dah jual lah tanah you. You jangan sampai sini, walaupun di sini masih ada cutting, perlu cut. Tapi sampai sini, tanah kawasan ni you dah buang lah, jangan simpan. So so your curve can drop down and at the end dia touch the zero line here. So that means sampai ujung tak ada lagi tanah nak buang. Because along the way dah start jual lah tanah. Tak payah tunggu sampai ujung. Sama juga kalau field borrow ataupun beli ya. Duduk. Kalau you perlu beli, going up meaning cut, going down field sampai ujung ni, banyak tak cukup, okay? Tanah tak cukup nak field sampai sini. So along the way, you dah beli lah tanah. Kat sini katakan jalan sampai rumah saya. Ya, doktor ada tanah je, ada. Dia beli, dia dah terus sampai ujung, tak payah sampai ujung. Kerana you dah awal you dah prepare for the shortage. So this is a example strategi lah to ensure that you tak perlu pergi balik dalam urusan transportation of soil. So the required amount of borrowed material obtained and added at this location to minimize haul distance by reducing the area under the best background. So maknanya your movement pun berkurang kalau you dah habis kat sini. So that's the strategy. Okay. Another thing, remember the transportation of soil? The term called point of economical haul. Haul is, remember, transport soil from one place to another place. Is where two or more borrow area. So in this case, kita aja you need to buy. You need to buy soil. Tadi macam tadi tu, you nak make sure the curve tu nicely and at zero. So you need to import soil and then for this location. So but you have two options. Saya pernah jual, ada kawan kita ujung Raja pernah jual tanah. Dia kata, ya aku ada. Saya ada. Nak pilih siapa? So this is decision making. This will help us in our decision making. We need to do some calculation as to where to start using the material from the first borrow and begin using the material from the next borrow. You have to get everything from me, get some from me and some from the others. But you need to know where to stop from getting the source from me, and where to start getting the source from the next one. Kau remember kita jalan kita jauh kan? Kita tak nak ambil seorang ni, ambil dekat satu toke aja, semua dia sampai, tapi tu nak jauh lagi. Padahal dekat sana pun ada. So, tapi we need to know what is the most economical point of economical haul. So, dalam example ni, ini highway dari ini North South Highway kita Selatan. Example saya ni. Tak tahu lah kampung siapa ni, kampung Lalang, kampung Bedangban, mana ni? Pendang, Kedah. Bedangban, Kedah lah. Okay, this is the highway. Yang perlukan borong. Memang kalau dia kena turun dalam star tu, semua pendang kan, topografi. Kalau tambah tu. Now, where do we get the soil? Dia ada dua quarry sekarang. Satu quarry 1 kilometer away from the highway. Quarry satu. Another quarry kat ujung highway ni dia ada 2 kilometer from the highway. Kemudian sebelum sampai ke highway dia ada lalu jalan biasa 2 kilometer. Ini lalu jalan biasa 1 kilometer. Quarry satu, quarry dua. So the distance of road ni atau highway ni 20 km. Panjang dia 20 km yang nak fit, right? So we want to know, kita nak ambil field yang ni, dia ambil lah dekat ujung ni, kawan ni dekat ujung ni. Tapi we want to know, kita nak ambil field sampai mana? Kita nak guna daripada ni, kita nak tambah sampai mana? Which is X. So I want to use quarry 1 to build X distance of the highway. X daripada 20. Berapa kilometer daripada 20 kilometer, I nak ambil daripada sini. Dan berapa kilometer daripada 20, nak ambil daripada quarry 2. So that is the economical analysis that we are trying to do here. So, but we need some data. This is the data. The point of economical haul occurs at the location where the total cost of excavating, excavation, and hauling transportation tadi, from quarry 1 is equal to the cost of excavating and hauling from quarry 2. Set the two conditions sama. Then you can find what is the distance that is most economic. Tapi we need data. Data untuk quarry 1, remember royalty. Quarry 1 to land office RM3 per meter cube. Mesti bayar RM3 pada land office. Setiap meter cube you keluar daripada tapak tu, daripada quarry, you bayar RM3. Quarry 2, royalty to land office RM2.84. Remember? There is another district. Dia lain. Ada bayar royalty daripada lain. Mungkin sama. Excavation cost RM2 per meter cube. Quarry 1 RM2.50 per meter cube for whatever reason lah, letak je. Haul, transport, sama 50 sen per kilometer. Now you cannot get 50 sen lah. This is during my time. So untuk cost untuk quarry 1, excavation, cost of excavation plus royalty plus haul, transport. Haul ni ada maklumat distance yang kita perlu tadi. What is the distance? 1 km daripada highway, dan juga plus X kilometer yang kita nak bawa dalam highway itself. Untuk quarry 2 sama juga, excavation plus royalty plus 2 km from highway and 20 minus X yang kita nak bawa ke highway. So we set this equation 1 and 2 to be equal, Q1 equal to Q2, so we can find the X. Now berdasarkan calculation ni, kita dapat X kita 9.8 km. So X kita dapat ni di matematiknya. So maknanya distance ni from here to here somewhere 9.8 km. Right? So if this 9.8, the remaining here would be 12.2. So 12.2 kita ambil dari quarry ni, 9.8 kita ambil dari quarry ni. That would be the most economical earthwork operation for this portion of the highway. So the economical distance is for Q1 1 km plus 9.8 10 km, Q2 2 km. Ini distance di luar the highway. Right? Alright, so that is about some, what you call it, consideration that you want to take if you are managing a road project. Okay, back to the freehold distance. We're finishing. Almost there. Number 4. Okay. How to? Sekarang tadi saya kata along the way banyak kefahaman now kan. Tapi kita nak dengar satu je standard freehold distance. How do we calculate that? What we need to do is we need to calculate setiap curve tu, setiap curve yang ada. After that we ambil average. Lepas kita ambil average. Average tu lah akan digunakan sebagai freehold. Freehold distance under the curve. Up and go out. Divide by the highest point. Remember, dia punya axis ni, ini y, which is the volume. This is the distance. Right? And bawah ni area. Volume. Distance. This is the area. Area under the curve. So area under the curve is meter cube meter, right? X multiplied by y, dapat area dia. Okay, katakan ni y, ni x, dia dapat area bawah dia. X multiplied by y dapat area ni kan. So that's why this is meter cube, distance is meter, so meter multiplied by meter cube. The peak pula kepada atas atau bawah valley is in meter cube. So freehold distance is area ini divide by the peak. Katakan area ialah 100 meter cube meter. The peak is 20 meter cube. So 100 divided by 20. So that means the freehold is 5. Which is not logical lah kan, 5 kali 1 meter. So but the calculation is like that. Area under the curve divided by the peak. Curve divided by the peak. So you got the freehold in meter. Because remember the area divided by meter, meter cube meter divided by meter, tinggal lah meter. The cube dah cross out lah. So that meter is what we call freehold distance. And this freehold distance ni, itu baru satu curve. You kena calculate untuk semua curve lah. Ada 1, 2, 3 lagi 4. Dan last kali semua freehold you dapat ni ambil average. Once you dah dapat average, then you letak dekat cross to line in the middle of the curve. You go to the left half of the average and the right half of the average. Then you know that is the free distance. Katakan you dapat average tadi 20 meter. So 20 meter ni, 20 meter ni. Tapi remember dah setengah curve dia kecil lah. So 20 meter boleh nama lebih. So dia free lah. Semua. Ada setengah 20 sini je. Hal lain tu overhaul. Kat sini tak ada overhaul, sini ada overhaul. Inilah. So that is the overhaul is only paid if you are outside of the balance point.